As I said initially, my name is Filip Gudjevski, and I am the QA Technology Team Lead at Scalefocus based out of Skopje, Macedonia. Okay, so let's go over the rounds that we'll go into. I divided them into rounds because basically it will be a match-off in each category between Cypress and Selenium. We'll go over the architecture, browser and language support, flaky tests, API testing, assertions, test summarization, hooks, and Cypress dashboard. Please, not another Selenium framework. This is one of my favorite memes, and don't worry, I have to tell you heads up, this is not going to be another version of a Selenium framework such as Test Cafe, Nightwatch, etc. So this is a purely different architecture from Selenium, and we're going to see why. So, round one. Initially, this is the Selenium architecture as you know it. Actually, this is the Selenium architecture for Selenium 3. So we have our language bindings, which we can use them with Java, C#, Python, or Ruby, which communicates over HTTP, called JSON Wire Protocol, with our browser drivers, which can be Chrome, Gecko, Safari, etc. And those browser drivers communicate with the web browsers back and forth. So, in reality, Selenium 3 architecture executes remote network commands, hence sending API calls over HTTP using the JSON Wire Protocol. And because of that, we never have access to the true state of our application. We're just sending a request and hoping for a response that our application is at the state that we wanted it to be, hence making our test more asynchronous and more flaky, which is why we are heavily dependent on wait for a hero helpers, such as wait for an element to be located, wait for element to be enabled, and whatnot. And this is a real problem because most of the applications these days, which are tested using automation tests, are either made using a synchronous request or single page application, which in reality return only a portion of the page and not reload the page itself. Here comes Cypress. Cypress has a completely different architecture, and the major difference is that it runs in the browser. So what we have is a Node.js process which opens the browser with a proxy and injects our test JavaScript file into the browser. So the Cypress tests are executed inside the browser as an iframe in the same run loop with the application. So if you pause the Cypress execution during the test, you can actually open the debug tool and see that Cypress tests are as a JavaScript module or an iframe inside the browser. How is that achieved? This is achieved through the Chrome DevTools protocol, upon which Cypress is built on. Chrome DevTools protocol is a chatty protocol that allows browser introspection. So basically, it allows us to see everything going on in the browser in real time. CDP is developed to enable a debugger inside Chromium-based browsers. I know some of you might say, well, I know that Cypress also supports Firefox as a web browser, and Firefox is not a Chromium-based one. That is true, but on the other hand, Firefox uses remote debugging protocol as its own proprietary technology, which implements a subset of CDP, which is why Cypress is able to support Firefox as one of the supported browsers. Let me give you a more simple example with pictures how Cypress works in the background. So we have our spec file, which would be go to Amazon, do some assertions on the page, click on the search bar, click on a test result. And the Node.js process, once started, takes our test.js file, packages it into a Node.js file, and as I said previously opens the browser with a proxy and injects our test as an iframe along with the application. So our tests have complete overview of the execution of the application, hence making our test more stable and avoiding the flakiness which we would have if running Selenium test using Selenium 3. Round two. As far as the browser support goes, it's expected Selenium to have more browser support because it's been on the market for more than 15 years, actually since 2004 when Jason Higgins created the first JavaScript test runner. So Selenium supports Chrome, Edge, Firefox, Opera, and Safari, while on the other hand, Cypress supports Chrome, Edge, Firefox, and its native Electron browser. As far as the language support goes, Selenium has a lot of language bindings to choose from, such as Java, C#, JavaScript, Python, Ruby, Perl, and PHP, while on the other hand, Cypress is JavaScript or bust. Of course, you can use TypeScript, but in reality, TypeScript is not another language. It's more like a superset of JavaScript, which the creators of Cypress said that Cypress is going to be used with JavaScript now until eternity. So that's kind of a bummer. Moving on to round three, the flakiness of the test. As I previously said, Cypress is executed inside the browser, and hence it has complete visibility of everything happening in the application synchronously. So for example, Cypress will never try to get an element if it sees that it's not there. Hence, it will avoid us of having exceptions like we would have in Selenium, such as no such element found or state element exception. There is almost no need to add implicit or explicit weights, such as expected conditions. Cypress automatically waits for elements to exist in the DOM. Cypress also calls this weights as intelligent weights. As you can see here, I bolded the almost word because as using Cypress for almost 2 years now, I've found myself in situations where not always Cypress handles the element enablement and the visibility in the HTML tree. So we do have to do some minor tweaks, but I would say in 99% of the cases, it handled the intelligent weighting on its own. The default timeout for automatic waits is 4 seconds, but this can be changed or overridden in the Cypress JSON file, which is basically the configuration file for Cypress under the default command timeout parameter. This is the example of what a test would look like if we had to implement the wrappers or helpers for wait for element to be located by a certain ID. As you can see here, we have a couple of extra lines of code. While on the other hand, doing this in Cypress is fairly easy. We just get the element by the ID, called submit button in this case, and just call the method click, and that's it. We don't need any waiters, any helpers. We don't need wait element to be located or enabled or whatnot. This is one of the trade-offs for Cypress, in my opinion. Moving on to round 4. API testing. Cypress supports API testing out of the box using the side request method. It supports all HTTP methods such as get, post, put, delete, etc. I know that some of you might say, well, we can also use API testing with Selenium, but yes, but not out of the box. In order to use API testing with Selenium, you need to add another dependencies or a library such as REST Assured, Tablet for Python, or REST Sharp for any unit. Cypress allows it out of the box by using the side request methods. It's fairly straightforward. Side request as a method has a lot of optional parameters, such as calling what kind of HTTP method we're going to get, which URL we're going to point at, the headers, and whatnot. The response is made by yielding the object as a response and doing some assertions on it. Here in this example, we're doing a check if the status code is 200 and iterating through each object of the JSON array and checking if it has all the mandatory keys in each object. Moving on to round 5, assertions. Cypress uses Chai assertion library out of the box, and its assertions can be divided into 2 main types of assertions. Implicit assertions, which are made on the obtained object, which means we yield the object, and we do certain assertions on the yielded objects. They cannot be used as standalone assertions and are often used for multiple checks. An example of this would be to check the parameters on the ID called greeting. So using the site-get command, we get the element or the object in this case, and we do multiple checks on it, like should be visible and have text who should be equals to hello there. The other types of assertions from Cypress is the explicit assertions, and those are used when we want to make assertion directly to an object. For example, the left scenario is using the expect assertion check. We basically check if the first list includes members from the second list, and the second one is done made using the assert keyword. Basically, we check objects. In this specific scenario, we check if person is an object or not. On the other hand, Selenium uses explicit assertions on its own, but it doesn't have built-in assertions. It's dependent on the testing framework which it uses. For example, if we use Java, we're going to use it with either TestNG or JUnit. If we're using .NET, we're going to be using NUnit, Python, PyTest, unit test, and so on. For example, the differences between Cypress and Selenium is that Cypress checks the properties of the element on the obtained object on the element, while on the other hand, Cypress extracts the value as either Boolean or a string or whatnot, and then compares it with an expected value or Boolean for that element. One of the biggest advantages which Selenium has over Cypress, in my opinion, is the option for soft assert. We all know this option for soft assert, where we have multiple verifications inside the test, and in the end, we do a assert all method, which can come quite handy because we don't want our test to fail if one of the verification fails. I've read somewhere online that there's an NPM library called SoftAssert, which we can achieve the same thing with Cypress. But since it's not officially supported by the Cypress community and the Cypress creators, I'm not sure how stable it is. But if you want, you can go ahead and have a try at it. Okay, moving on to round 6. The test organization. Cypress has a predefined project structure, and specific parts of the codes must be in specific directories for them to work. For example, when you install Cypress on your local machine, by default, it installs these folders and these files. The fixtures folder is for storing test data. The integration folder is where we still store our test files, or according to Mocha, spec files. The plugins folder, which is used to write code to extend the behavior of the Cypress spec files. The screenshots folder, which is used to store and save the screenshots for failures. We can also override it to save screenshots of past executions as well. Support directory, which is used for writing reusable code, such as APIs and module exports for before execution and after execution. And we have our Cypress JSON configuration file, which we can implement all sorts of things which can be implemented for our entire Cypress project, such as default command timeout, wait time for request, wait time for response, and whatnot. Well, on the other hand, Selenium doesn't have a strict predefined project structure like we have with Cypress. We can view each Selenium project as a development project and organize it and implement the design pattern as much as we want. So for example, we can have main and test modules. We can have resources in both main and test modules and organize the screenshots and folders in each directory that we want. Okay, moving on to round 7. Hooks. Cypress uses Mocha as a testing framework, and it offers before each, after, and after each, and other annotations as hooks. While on the other hand, depending on the language binding which we use and the testing framework, Selenium has before suit, before class, before method, and after class. You can see on the left picture that this is the example of a spec file. In the describe block, we have our before each, and after. And on the right picture, we have before suit, and before test, after test. One of the biggest advantages which Selenium has over Cypress is because it's an object-oriented language, it allows us to have a base test class, which extends to all other test classes inside the project. While on the other hand, spec files or test files in Cypress cannot be extended. And if we want to have a function which would be before, when we want to be executed once before all spec files in our test projects, we can't achieve that. And before each must be placed in each spec files in order to be run before each block while executing our test. So in my opinion, that's a big win for Selenium and the language bindings it uses. Okay, moving on to round 8, the dashboard. Cypress provides a complementary dashboard. There are multiple plans, including a free tier 1. Depending on the plan we can get extensive insight of our tests, such as flaky management test. It tells us which of our tests after multiple executions tend to be more flaky or not, which tests execute more faster, which tests execute more slower, which tests are dependent on network lagging, latency, and similar. It simplifies parallel execution because Cypress does not offer parallel execution out of the box like we would have with Selenium. For example, in Selenium Java, we can just add as much threads as we want in our XML file, and we can have multiple parallel execution on a local machine. Well, on the other hand, parallel execution can only be done using CI runners. That is by matching simultaneous parallel runs on different CI runners or on VM machines. Of course, we can achieve on a local machine using Docker, but that's not the native approach for parallel execution. One of the other complementary dashboard options is the automatic load balancing. So based on previous runs, for example, if we have 10 tests and we have 3 tests in one CI runner and 7 in the other one, the Cypress dashboard sees the previous execution time on all of the tests and basically matches both CI runners to have the exact load when it runs to execute in the same time. So basically we have 5 tests on one CI runner to execute at the same time with the other 5 tests on the CI runner. And it also simplifies the integration with multiple CI providers such as Circle CI, Bitrise, GitHub Actions, and whatnot. Okay, keynotes to remember from this presentation. Cypress does not use WebDriver under the hood. Cypress uses automatic waiting or intelligent waiting, so we don't need to use custom waits anymore, such as wait for element to locate it, enabled and whatnot, Cypress cannot visit multiple domains from different origins in a single test. Unlike Selenium, which we can use to visit different domains in one execution or in one test class, Cypress does not allow multiple browser instances because it runs in the browser. Hence, it cannot allow parallel execution on a local machine. While on the other hand, we all know that we can start as many instances of browsers as we want in one Selenium run, that is as much as our machine can handle. And one of the biggest, I would say, losing points for Cypress is Cypress does not support multiple tabs, even though it can. If we go into the documentation for Cypress, they said that they have the API for multiple browser support, but according to Cypress, that's not the way that the modern web should be tested. And even though they can implement it, they've decided to not implement it, and that's their stand for the near future. And again, one of the trade-offs for Cypress is the integrated API testing support, which I previously said. Okay, so it's now time to declare the winner. Again, I'm going to say this is my biased opinion, and even though the presentation is called Cypress versus Selenium, David versus Goliath, we all know, according to the legend, David as the underdog beats Goliath, who is the favorite. And that was the case up until a month ago when Simon Stewart released the stable version of Selenium 4, which has the Chrome DevTools protocol implemented as a much more friendly API than the one Cypress uses. And also, it excludes the JSON wire protocol and implements the W3C WebDriver protocol, which we all know is the standard for WebDriver communication and the protocol for modern browsers. So that being said, I would have to choose that my winner in this stand-up would be Selenium 4. I know this is my biased opinion, and we can all have different feelings and objections about it, but I'm open to discussion. That being said, I think that my time for presentation is up, and it's your turn for Q&A.
Cypress deals with frames?
No, that's one of the biggest blockers for Cypress. Officially, it can deal with iframes, not as out of the box as it can Selenium handle switching to multiple iframes, but you have to write custom codes in support and index.js in order to provide that. It's not so native, but it can be implemented.
Okay, nice. And another question, which is Selenium is a browser automation API, whereas Cypress is full-fledged test automation framework, incorporating, as you mentioned, tools such as Mocha and Chai. Aren't you comparing apples with oranges?
Sorry, can you repeat the last part?
The question is whether you are comparing apples with oranges. It's more like, isn't they kind of different things?
Yes, someone might say that because, as I said in the beginning, Selenium is a browser automation tool, while on the other hand, Cypress is a complete testing experience, which it has incorporated Chai and Mocha as a testing libraries and testing framework. But again, this is the comparison of the two tools. You can also call Cypress as a tool. And even though the comparison of apples versus oranges might stand, everybody uses Cypress and Selenium on a daily level. So I think it's a fair comparison of the two tools.
Thanks. And another question, what is it Cypress better in compared to Selenium, and what is it Selenium better than Cypress?
Well, I would have to say that the trade-off that Selenium has over Cypress is the fact that it can run multiple browser instances on the same machine. And one of the biggest trade-offs is that it can handle multiple tabs. Well, on the other hand, I found Cypress to be much faster in executing tests and to not worry about the flakiness of the test when we have a single page application and a synchronous request. So I would say Selenium bonus points for multiple browser instances and browser versions for that matter. And Cypress definitely for the intelligent automatic waits and the integrated API testing support.
Great. Thanks a lot. I don't see any other questions in the chat. So thank you for your presentation. It was really interesting to see this comparison. And thank you for being here with us.
Thank you for having me as a presenter, and wish you best of luck to the next presenters in the ISTO conference.
Thank you.